Welcome to the first lesson on electrochemistry. Now we all use batteries, and batteries are actually electrochemistry. For example, here we have a lemon, and in this lemon are ions, and when ions and electrons flow, they generate electricity like this, where this instrument is measuring the amount of energy or electricity generated by the flow of electrons in this system, which is now just a little bit of amperes. Okay, so the first thing we need to recap before we go to electrochemistry is oxidation and reduction reactions. Now you've done this before, but this is very important and there can be no confusion after this lesson on oxidation and reduction. So oxidation is the loss of electrons and reduction is the gain of electrons. An elemental compound that loses electrons is oxidized. An elemental compound that gains electrons is reduced. Now let's take this for an example. Here you have zinc solid going to zinc plus 2 ions, giving off 2 electrons. Now in this example, the zinc is losing electrons. It's losing 2 electrons. Therefore the zinc is oxidized, because oxidized means losing electrons. The zinc gives its electrons away and therefore reduces some other compound that's not shown here. So therefore the zinc can also be called a reducing agent. Now this can be confusing because the zinc is oxidized, but it is also a reducing agent because while it is oxidized, it is reducing something else. And it's very important to understand this clearly. The zinc's oxidation number is 0 in this case. When it goes to zinc plus 2, you can conclude that it's losing electrons because the charge is more positive. Plus 2 is more positive than 0. And zinc is then a reducing agent because it's giving its electrons to something else and is therefore reducing something else. Let's look at this example. Here you have copper 2 plus 2 electrons, giving you copper 0. Now in this case, the copper plus 2 gets 2 electrons, therefore it gains electrons and is reduced. Why do we call it reduced? Because the oxidation number is reducing. It's getting lower. From plus 2 to 0. It is decreasing. It is reducing. Copper plus 2 takes electrons away from some other compound in this process. And therefore, the copper plus 2 is oxidizing another element or compound, and therefore the copper plus 2 is also an oxidizing agent. This is very important. Copper plus 2 gains 2 electrons and is therefore reduced, but it is also oxidizing something else. Now let's look at this example. We want to determine in this half reaction if the ion is being oxidized or reduced. Here the charge on the ion is 0 and then it's going to ion plus 2. So therefore the oxidation number is increasing, it's getting more, and that tells us that this is oxidation. The ion is oxidized. Let's look at another one. We have ion 3 plus going to ion 2 plus. Therefore, the charge on the ion is decreasing or reducing. and therefore we say that iron 3 plus is reduced. This is a more difficult one. Here we have iron oxide, which we can't just say the charge is this, because this is now a compound, not an element. Therefore, you have to calculate the oxidation number of the iron. Now, you know that oxygen is also always -2. So, you know that the oxygen's charge is -2 times 3 because there's 3 oxygens. The charge on the whole compound is 0. So, therefore, the iron must be charged +3 because +3 times 2, because there's 2 ions, gives you 0. +6 minus 6 is 0. So this is a way to calculate an oxidation number if the molecule oxidized or reduced is a compound, not an element that you can easily see the charge. So you go from the oxygen. Oxygen is -2 times 3 is -6. So now the other part of the compound should be +6. There's 2 ions, so 1 ion must be +3. Because +6 minus 6 gives you 0. Now let's see. If iron here is +3 and it goes to iron 0, then the oxidation number is reducing, and therefore this iron species is reduced. Last example. Iron +2 going to iron +3. The oxidation number increased, and therefore you have oxidized that iron +2.